Good afternoon, everyone. Today we're going to continue our discussion on machine learning uh, for regression. Okay, so what we're going to do now is we're going to use a data that's very much used when in your thesis. So there are many researchers that that use for example, the exchange rate, the U.S. dollar Philippine exchange rate. So that's what we're going to use today. So we're going to make use of, we're not going to reach the algorithms yet because we'll have to clean the data. We're going to learn how to clean the data. So, but the objective is to compare the decision tree, random forest, SVM, XGBoost, and ANN for the data that we're going to use. Okay, I'll just provide, here are some journal articles that you can use. Okay, and then the features, we're going to discuss it in greater detail. So let's first load our packages. So this is the first time that I'm sharing with you. Uh, okay, this one plus. Um, so we're going to use the following packages: quant mode, technical trading rules, tidyverse, etc. There are many packages here, most of which we already have installed before. Okay, so we're just creating this vector called packages, and then we're going to use pacman. Okay, if pacman is available, then no need to install. Okay, but we have already installed it before. And then here, class, we're going to use this function suppress package startup messages. Okay, because usually when you install packages or require packages, you get so many messages, the dependencies, etc. So what we're going to do here is that we're just going to suppress the startup messages. Okay, pacman, payload, and then we have to define the character class. 29. Character, okay, character. We can't directly feed packages here, class, in pacman. We have to state that this is character from this is the character vector. Okay, install is equal to true and then not update. So let's run this class. Okay, and you notice when it runs the packages, it installs in case if it's not yet installed. Notice there are no startup messages that you get. Okay, kindly confirm, class, if you were able to install and load the packages without the messages. The messages were suppressed, class. So this is the function for that. I'll wait for your feedback. Okay, good. Okay, thank you. So I hope everybody was able to load the packages and then no startup messages were received because we imposed this. Okay, so the packages are already uh, ready. Let's just test one, class. So go to packages and let's see. TTR is already checked. E1071, let's check E1071. Okay, also check. Okay. XGBoost and NNet for artificial neural network. NNet. Okay. All right. So we're done. We're okay with the packages now. All right, so we're going to download US dollar Philippine peso exchange rate. Let's identify first the start date and the end date. I'll not share this with you. You just type this class. Let's start with 2015-01-01 up to end of 2024, 12/31. Okay, I hope you have done that. Uh, I'll just give you a few more seconds. Okay, maybe let's change this. Uh, I'll just change this class. USDPHP. Okay, I have to change this. Okay. All right. So let's now class download the uh, US dollar USD Philippine peso exchange rate. The ticker symbol is this one. USDPHP is equal to X exchange rate. Okay. So we already did before the get symbols function up to this one class. I'm introducing to you another, let's say, level, another layer of generating or downloading stock prices. Okay, I'm including here try catch. So the try catch function, in case there are errors, class, it gives us a clearer message, class. Okay, so after auto.assign is equal to false, and then we put here error is equal to function e. So what's our function e? It's stop. Okay. So if it doesn't load, if there's a problem with loading the data from the get symbols function, stop, and then we give this message failed to download USD is equal to PHPX, whatever the ticker symbol is. And then also include the message class of the error. So it gives us a clear error message. Okay, it gives us additional message, additional input from the if there's an error. Okay, all right. So once we have once we have created this object, which is the US dollar Philippine peso exchange rate from 2015-01-01 to 2024-12/31, which is this one class. Then what do we do? Okay, we get the closing prices. So this should be closing USD PHP. Okay, USD USD PHP USD PHP. So we're just subsetting. We're getting the closing price, and then change the column name, and then check how many missing values we have. Okay. So okay, let me just share this in the interest of time. Control C, Control V. Okay, so take a look at this class. I've explained the try catch. This, the get symbols. We just included here try catch. Okay. And then, as I said, once we create the XS object, USDPHP, we just get the closing price, and then we change the column name into USDPHP, and then check how many missing values do we have. Okay. So let's run this first. This is a vector. Okay, symbol FX, just a character. And then let's run this, Control Enter. And then, therefore, class, we would have generated the USD PHP object, right? Let's see. USD PHP, which is an XTS, as expected. It's an XTS object, OHLC, a volume, and then adjusted here. We know this class. Notice that there are no volumes, no? And when we run that class, what does it tell us here? Is there a message? Yes, there's a message here. Warning, USDPHP contains missing values. Some functions will not work if objects contain missing values in the middle of the series. Consider using an a.omit, an a.approximate, an a.fill, etc. to remove or replace them. Okay, so let's check class if there's a missing value here. First we get this. No? Where's that? First we just get the closing price here. Get the closing price only. Control enter. And then you have USDPHP. So there, you only have one, right? This is the closing price. And then let's change this. Let's change the name. Column names of USDPHP will be USDPHP there. Okay, so you now have this one. So there, UHDPHP. There are 2609 entries, 2609 observations. And then let's check if there are missing values. Let's get the sum of USDPHP. So there are three missing values. Okay, and we know very well, class, that with missing values, you'll have uh, you cannot perform some uh, codes on that class, statistical or whatever operations. Okay, then we're going to download also two other variables that we're going to use also as predictors for USDPHP. So what we're going to study here is we're going to regress USDPHP on several variables. So you may copy this class and then change the USDPHP. Of course, make sure that you change also the others here. Number one is let's use the volatility index, VIX. So VIX is an index that measures the volatility, VIX here. So it's just like the GSPC class. Okay, and another one, the Brent oil price is equal to, let me see, check class in Brent, no? Brent oil prices, is it, the ticker symbol, is it equal to BF is equal to X? Kindly check na lang, no? And then I suggest that you copy this class, do the same for VIX, copy it again and do the same for BF, for Brent oil prices. So you'll have now three assets there, the USDPHP, and then the VIX. Okay, you can name this class so that we have the same names. Okay. You can use, we can use the name VIX, VIX class for the volatility index and for Brent, BRENT. Okay, so that we have the same names class, so that if I am going to share with you some codes, let's use to avoid errors in our codes because if ever I'm going to share with you some codes, so create this object VIX class here. Also create the object Brent, don't capitalize it. No reason whatsoever not to capitalize. It's just so that we have the same, we're just making it uniform. Okay. And the name for the column names is also VIX and Brent. Okay, I'll give you a few seconds, class, to please download also volatility index, also from Yahoo, and Brent. Same dates. Okay, and once you're done, kindly please check also how many NAs does VIX have and also how many NAs does Brent have. Once you're done, kindly please uh, give your comments on the chat box. Waiting for your response, class. Mahaba pala, sorry. Be sure to change the names, no? Where appropriate. And yet, for VIX class, the same thing. We're just changing the symbol. Symbol for VIX will be caret VIX, and then make sure to change this class, no? Symbol VIX, so that it refers here. And just change this. Okay, and then VIX, just get the closing price of the VIX dataset. Column names, change the column names again, and then get the number of missing values. So I'll run this symbol VIX. I'll run it one at a time. So I'll first get the object, the VIX object. Control Enter. And then if I check VIX class, let me check VIX here. VIX, this is our VIX class. 2607 observations. Okay, you can see here NAs already. NAs, but not 17. So let's just get the closing price. I'm getting closing class VIX, closing of the, I'll overwrite the original VIX class. Okay. And then column names, I'll change it because VIX has a VIX.closing column name, yeah. I'll just make it VIX. And then, okay. Would you want to answer again, class? How many missing values you have? A bit faster, class, if possible. How many now? How many missing values do you have? Is it still 1747? So that means most of this class will be missing values. Hindi naman. Okay? It's not 1747. Definitely, class. Missing yan eh. There are 2607 observations. I don't see how this can be missing 1747. All right, 92 lang, correct, no? 92 lang, class. 92 lang yung missing values. Where did you get wrong, class? 1747. Saan nagaling yan? Moises, where did that come from? The 1747.
Sir, mali po yung na-type na ticker symbol. May
Okay.
kulang po.
Kulang karet?
Opo, sir.
Okay.
Na-miss out po kanina.
Okay. All right. May caret class kasi volatility index yung maybe there's another asset called VIX, but the one that we're referring to is an index. And we'd like to see if this affects the US dollar exchange rate together with for Brent class. Okay, I'll just show it to you. Okay, Brent will have, let me run everything here. Okay, sum is .NA, then Brent. Control Enter. So only two missing values. Okay, so I just place it in one code here, class. You may do this if you want. Okay, but we don't need this anymore kasi we already did this. Okay, let me pause for a while, class, and seek your feedback if you're able to follow. I hope more will answer, class. I hope you got 92, class, no? 92. Three, three missing values for USDPHP, 92 for VIX, and 2 for Brent. Could you kindly confirm, class, if you got the same answer? Okay, thank you. Few more seconds for the others to catch up. Okay, okay. All right. Now, what do we do with this class? That's the next thing to do. We don't just immediately jump to machine learning. We have to clean our data first. And the process of cleaning, fixing your data is called data wrangling. No? We have to wrangle with our data first. Okay, let me just write that for the information of everyone. So that's what we call data wrangling. Cleaning your data, preparing them, okay, for data analysis. So we have to wrangle with the data wrangling. So one of the things that we have to do here is we have to address this. We have to address these missing values. Okay, we just can't let that be because our code will not run with missing values. Okay, so what do we do, class? The most significant class is VIX. Okay, 92 missing values. So if we check class, if we check our VIX data here, so here there's an NA here, NA here, NA here, NA here, 92 NAs all in all. Okay, now if we were just analyzing a univariate data, let's say we're just going to model the time series VIX, then one good way to address the missing values is what we call last observation carried forward, LOCF class. LOCF. Okay? Last observation carried forward. And it makes sense because here there's a missing value class, NA. Okay, could have been a holiday, so there was no value. So it makes sense to make the previous observation 15.74, right? It makes sense because let's say this was a holiday, then technically the price of VIX uh, for today would still be the same, 15.74. Okay, so we can do that, class. And how do we do that? So let's illustrate that. Okay, let's illustrate how we do last observation carried forward. So here, class, I want you to write this. Let's create another object, VIX LOCF, and we're using from the zoo package na.locf. So it means that for all the NAs, we use last observation carried forward for VIX. And then let's view now this object called VIX LOCF. And then let's count how many missing values are there for VIX LOCF. Okay, so kindly answer, class, how many missing values will there be? If we do imputation, class, if we carry forward, if we move forward, class, the previous value that's the previous value, the latest previous value for a value that's missing. So what happens, class, if we perform that? All right, thank you, Moses. Okay, 0. How about for the others? Okay, 0 then. Okay, good, good. Okay, so that means, class, that when we run this, we're creating this object VIX LOCF. Okay, and if I, this is VIX LOCF already there. VIX LOCF, and notice that there are no missing values. No more missing values because we performed LOCF. Okay, it's not always, class, that this is not always the best method, because it's possible that you have so many consecutive, no, for whatever reason. Say you have 10 days no value. Okay, and LOCF might not be a good method for that. LOCF is best works if we are still justified in getting the last observation. If there's only one or two missed values, but if there are, uh, let's say, 5, 6, 7, so that might not be a good idea, class. So there may be another way, other ways in order to do that. Okay, so let's go back to our method. Okay, now that we have, shown that using LOCF, class, would fill in some details or that it will address the NAs. Okay, take note, class, that we're not using, this is not a univariate time series analysis. When I say not a univariate time series analysis, we're not just analyzing VIX. VIX is just one of the variables. We're also analyzing USDPHP and also Brent. So the question is, will this method of doing LOCF for VIX first and then merging your data, will that work? Okay, so what we're going to do now is we're going to compare and see what's the best way to treat the NA values. Okay, so I'll share this with you, class. Just some notes here. Okay, so let's take a look at this briefly, the notes that I provided you with. Okay, the first method that we're going to do is first do an inner join. Okay, what's an inner join, class? Okay, let me just illustrate that. An inner join is, for example, you have these dates. Let's say January 1, January 2, January 3, January 4, January 5. Okay, an inner join is, let's say, asset A, asset B, asset C. So let's say we have values here, okay? Then you don't have a value here. You have here. Then you have a value here, but you don't have here. Then you have values here, and then here. When you say inner join, class, what will happen is that only those values that are present in all your variables or your data, okay, will be included. So this will be removed too. This will be removed also. Okay. In other words, class, if there's any missing value in any of your variables, then that will be removed. So that's what we call your inner join. However, class, the inner join function only works, this specific function, class, join. This will only work if you have two variables, class. If there's three, then we can just use the merge function. Actually, we can still use join inner. Okay, it will still work, but it will default to the merge function. Okay, let's show that, class. Okay, so we're now going to the first method, class, no? Here. So I want you to write this. Let's now merge first. Merge USD, VIX, Brent, and all class. All is equal to true. It means that all the dates for USD will be included. All the dates for VIX will be included. All the dates for Brent will be included. Okay, and let's see what happens, class, when we include all the dates for all the variables. Okay, may I ask you, class, how many observations do we now have for merged union, class? How many observations is this data when we include USD, VIX, and Brent? All is equal to true. How many observations? Kindly please chat in the chat box. Can use end row, class, to determine the number of observations for the merged, for this object merged. Okay, waiting for your answer, class. Taking it so long, class. Come on. Feedback. I'm just asking for how many observations does the merged union, class, huh? This one. Where you merge USD, VIX, and Brent all. Moises, yung question ko, all. This one. Not not omitting the NAs. Just this one, merged union. How many observations? Okay, 2915. How about the others, class? How about the others? 2915, 2915. Okay. All right. Yes, you're correct. 2915, class. Okay. So let me run this. Control enter. And then let me check merged union, class. Merged union. I'll print this here. So you have now merged this one, class. And it's 2915. Now, let's just check, class. How many observations does USD PHP have? USD PHP has 2609. VIX has, Brent has 2516. VIX has 2607. So now, if you take a look at the merge, class, it's much larger than than all of the three. Why, class? Because it includes all the dates for USD, PHP, VIX, and Brent, regardless of whether they have values for that one. Take a look at this one, class. In this case, okay, 11, 12, 13. Okay, I'm wondering why this is NA. So if the asset does not have a value there, that date will still be included because the others have values there. So that's why you have a bigger number of observations if you just merged it. But we can now use the na.omit. Okay, na.omit for merge. So this is the same as, this is equivalent to the inner join class. INNER, inner join, which means you merge the data and then remove all that are and in anyone that's missing. So merged inner, let me run that. And then you can check here, merged inner, here class. Yeah, you're correct. 2214, but you don't have any more a missing value. So we can now use this class, this merged inner. Let me just, all right. And then I'll just share this with you, class, Control C, for you to, for us to print, class. So let's print union rows, number of rows of merged union. Okay, there's a difference between small n and big N, class. I explained that here, I think below here, later. So here, inner rows also for the merged inner. Okay, and then let's get the percent. N row merged inner, how many was retained, class? Divided by the total merged union. If I run everything here, you can see that 76% of the observations were retained. Okay? Of the total 2915, 2214 was retained, which means 76%, class. Okay. So, class, if we just merge everything, okay, and then get the inner join or omit, just remove the NAs, we'll have 2214 observations. Okay. So this is what will be left. Because we can choose 2915, class. There are NAs there. There are missing values there. So what we can do is to use 2214. All right. Now, the other option is this one. The other option is to first do LOCF. Okay. Do some imputation by filling in the values that's missing in VIX. And then after that, we merge. And when we delete the NAs. Let's see if that's a better idea. Now, take note, the disadvantage of that is that we're imputing values that are not really there. So there are missing values for VIX. We say that we use LOCF, which means that the previous value should be imputed in VIX. We say that that's good if we're only dealing with multivariate, with univariate data analysis. If it's only VIX that we're studying, if it's only VIX that we're modeling, then that's okay. However, if we're now having multivariates, class, multivariate data, then that might be questionable. Okay, so let's do that. First, okay, let's create this. Okay, we did this already, class. Let's determine how many. So before the merger, class, how many missing values are there in VIX? We know that already. That's 92. Okay, there NA before the merging. That's 92. And then, class, once we have included, okay, and then this one, class, let's compute how many missing values are there when we merge the USDPHP, VIX, Brent. Okay, this is our this class. This is our merge union where we merge everything. But what we're going to do is count how many NAs are there in USDPHP, VIX, and Brent. Okay, so let's run this, class. Control Enter. Ups. I'm going to give you time. Okay, I'll just give you the comment here. Okay, wait. Okay, now I better give you everything, class, so that we can save on time. Here, Control C. It's too long. Still too long. So copy everything first, class. And once you've copied it, kindly please chat. Are you done, class? Okay, thank you. All right. So let's check, class, what the code is. Okay, we did this already. There are 92 missing values for VIX. Now let's count how many are missing when we merge all of them, class. How many are missing? Okay, take note, when we merge all of them, we're creating an object that has 2,900 plus observations. Okay, because we're going to include those dates that are missing in all the dates, class. Whether it's all those dates in USD, PHP, all those dates in VIX and Brent, class. So let's run this and see what's the breakdown. Here. Okay, take a look at this, class. NA before the union, class. So when we merge USD, VIX, and your Brent, class, just merging it without removing the NAs, USD PHP has 309 missing values. VIX has 400 and Brent has 401. And this is because we merged the data. Class. Now what we do now is after merging, after getting how many are missing when we just merge it, okay? Okay, so let's see here. Let's run this print out here. Just the same class, huh? Here. 309, 400, 401. Okay. Now, let's now do an LOCF first. So remember, class, what we're going to do is we would like to, before we merge them, we would like to first get uh, do LOCF for VIX, just like what we did a while ago. So let's create this new object, VIX forward fill, okay, and we're using zoo na.locf, and then remove any NA class. Okay, Control Enter. So VIX FF now class will be just like this is what we did a while ago, NA dot LOCF, right? Here. So no more missing values. Okay, we remove the 92 missing values. Can just double check class here. NA.omit. Okay. So now we have VIX FFF class. If you get nen row of VIX FF, how many rows does this have, class? 2607. Okay, wait. Yeah, and then sum is .na VIX Are there missing values class in VIX FF? Control Enter. No missing values. Okay, so we expected this because we performed NA.all LOCF. Okay, now what we're going to do? We're going to use this class, this one, VIX FF. Okay, there are no missing values here. Okay, now this one class, this is the one that I just did a while ago. Okay, let me just join these two. All right. Okay, now what are we doing here, class? Let's see how many observations were filled. Let's take a look at this. Field VIX is how many observations, okay, before we did LOCF for VIX, and how many, okay, take note, NA before VIX is a number of NAs, okay, and NA after is the number of NAs class here. Okay, let's see. And then let's run this, Control Enter. Okay, so you can see here, class, that the NAs before was 92, and after LOCF, no more NAs. And how many were filled up? 92. So that's just, we're just counting how many were filled up. And we know that it's 92 because we use LOCF. Okay. Okay, so we're done with the LOCF. We're done with this. We counted how many were filled up. Now let's merge. Okay, what are we going to merge? Merge after the LOCF class. What we're merging is US dollar, okay, VIX, okay, FF class. This is the one that we treated for LOCF, okay, no missing values though, and then Brent, and then join is equal to inner class. So I said, class, a while ago that if you do join inner join class, this will generate an error term because the join is equal to inner is only good for 2 data sets. But that's okay because it will default to the merge here, class. It will default to this one, the merge class. All right, so I hope that's clear, class. Let's run this now. Run this. We now have a merge data. Control Enter. And then we're going to omit, class. We're going to remove any missing values. This one. This is like the merged inner class. Merged after VIX. We merge US dollar, VIX, the VIX that has been subjected to LOCF, and then Brent. Okay, Control Enter. And then we just print class here. Let's compare the number of rows with the original, the union, number of rows merged inner, and then also the rows if we did LOCF, okay, and then how many percent were retained. Let's take a look at this one, class. Let's run. Okay. So originally when we merged it, class, there were 2915. You recall this. And then when we removed the missing values, there were only 2214. So this was the first method using the inner method, inner join, without the LOCF. Now for the next one, class, if we used LOCF, so we first do the last observation carried forward, and then after that, we do the inner join. And you notice, class, that 22.15 were retained. Okay? If we just did the inner join, 2214 will be retained. So not much difference. They're practically the same. 76% also. A while ago, we saw that if we just do the inner join, 76% will be the retention rate. It took us 76% then. So what's the implication? The implication, class, is this. When you do LOCF, okay, you are doing imputation. You are quote unquote forcing a value to be placed in a date that in a place that there were no existing value in the first place. Okay, so that's imputation. That's okay, class, if you're just doing univariate. If we're just modeling VIX, no problem with that. That will be good because we're able to increase our data set. However, when we're merging it with other data sets, then that can be a problem, class. And if the benefit of doing that is practically nothing, class, di ba? Wala namang difference, class, eh, between just doing merge and then merge NA dot omit. And then ito, nag-LOCF pa tayo, tapos nag-inner join. If it's quite a big number of observations, class, kunyari 80 plus, no? Okay, then 80 plus kasi pag ang difference, mga 5% ng malaki, 2,000 class, eh. Diba? So that would mean mga 100 plus observations. That's kind of big. Okay, but it's practically the same, 76%. Tapos one observation lang. Diba? So what's the verdict, class? No net gain. No, no net gain. Okay, so the better option will just be to proceed with the inner join. Okay, it only keeps only the dates where all the three series truly exist, and it avoids introducing stale or fake values. Okay, okay, let me share this with you, class. So for this class, for this, okay, it can be in another data set, can be different. Baka malaki masyado yung difference kung if we do all LOCF first, perhaps we would have more 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 observations retained, class, if we do all LOCF first. Okay. All right. So for this one, again, I'll just let's just count, class. Control C. All right. So here, so this is what we're going to use, class. No, we're not going to use the LOCF plus inner join. We're just going to use this one, the one that we used a while ago. Okay, so this is just a repeat of what we did a while ago. Merge union, merge USD, PHP, VIX, and Brent, and then omit, remove the missing values. And then let's just, once again, this is just a repeat of what we did last time. Okay, if you run this, class, then you can see here 76%, class. Pretty much the same thing as your LOCF plus your inner join. Okay? Pause for a while ako, class. Kindly please chat in the chat box if you're able to follow. Okay, good, good. Okay, I hope you're learning something today. LOCF, I don't know if you discussed that in your other subjects. So this is part of data wrangling, and before we go to the main machine learning, we just have to make sure that our data is clean. Okay. All right. So let's now go here, class. I'll just share with you not everything here. I'll first ask you to let's compute now for the return. Okay, log returns of the US dollar. Okay, and you know this is coming from quant mode, daily return. Okay, and then we're using the merged inner, class. Okay, take note, class, this is what we're using, the merged inner. Okay, that's where your USD PHP, your VIX, and your Brent dataset are housed. Okay, and then what are we doing here? Okay, you know that this is subset. We're just getting the first, the second variable. Okay, let me just show again merged inner. Where's that? This is merged inner, class. Okay, merged inner, US dollar, VIX, and Brent. So what we're doing here is we are subsetting this first, and we're getting the daily return of this one. So that's what we're creating here. We're creating this object, USD PHP ret. And we're using daily return, and then type is equal to log. So that's the logarithm. Okay. Daily return of what class? Merged inner, and then just subset the USDPHP. And then you have to do the same thing for VIX ret. Okay. VIX return, daily return also, merged inner of the object VIX. So this is our merged inner, that's your VIX, and also your Brent. So do the same thing for VIX and Brent. Okay, I'll give you a few seconds, please, to do this. And then please type target also. I'll explain this one. I'll just provide you with this one, class. Explanation for the target, Control C. That's what I'm going to share with you. The others, class, please. Okay. Put this as a comment for target. When you're done, class, kindly please. Okay, thank you, Moises. Okay, good. Okay, all right. All right. So let's first, I'll run this first and see and compare, class. Control Enter. So you now have an XTS object, one column here, USD PHP ret. Okay, so this is your daily returns for US dollar, US PHP, USD PHP, and then also for VIX. I'll run this, and then we'll have our VIX ret. It's also daily returns here, and then our Brent. Okay, and then we're creating this class target. Now this is very important. Okay, and we're using log again. What are we going to log? We're going to log. Okay, we're going to log the returns. This one, class, the PHP returns. We're going to get the log of that. K is equal to 1. Okay, if you recall, class, what does K is equal to 1 mean? K is equal to negative 1. If it's K is equal to 1, then it will move forward, right? It will move forward, and the last one will be a missing value. On the other hand, class, this is different. No? Okay, so let me just get here for us to plot the head USD PHP ret. Then first 3, and then last 3 tail. Okay. So first 3, class, and then the last 3. So what happens, class, to our target? To the target data set. Where's that? Here. So let me run it also. Here. Okay, that's my target. And I'm going to get also the Let's compare class target head, target 3, tail, target 3. I'll run this. Let me clean this first. Okay, what do you notice, class? So this is your daily returns for, this is for USDPHP. And this one is for your target, right? What happened, class? Notice, just like before, class, we did this before, the second to the it actually moved, okay, backwards, class, right? So yung last value, class, dun sa USD PHP, which is 0.0103, okay, that now became the second to the last. In other words, class, moved it back. So nagka-NA tayo dito sa target. Okay, that's what happened, no, with target. So if we check target, class, remember, class, pag positive, it will move forward. Pag negative, class, it will move backwards. So, asan yung target ko here? Okay, we'll still need to change the names, no? Okay, here. Okay, may NA na tayo dito. We have an NA here, class, sa target. And I want us to just take a look at the rationale for this, class. Why are we doing this target? What's happening now? Let's merge it first, class, here. Okay. So here, class, almost time. I want you to write this, class. We're now creating this object, final underscore XTS. Okay. We're going to merge and then make sure that the NAs are omitted. Okay. Merge the return. Okay. Remember, we created the returns, no? USD PHP returns, VIX returns, Brent returns, and then target. Okay. What will happen is that it will remove the first row because there's an NA there, the latest one. Okay. And then let's change the column names. Let's make it USD PHP ret, VIX ret, Brent ret, and still maintain target. Okay, so I'll give you a few seconds. It's almost time. Okay, so that you should have, class, this final XTS. Okay, let me check. Sum is dot NA final underscore XTS. I'll run everything. All right, so no missing values. Final XTS should look like this one. There you go. And then there's this one last code before we call it a day. So we have this XTS object. I'll just share this with you in the interest of time, class. Control C. We're just going to create this time, this is an XTS object here. We're going to create a table class. You know what a table is, right? Here, it's a table. So same thing, okay? We're going to create a data frame where the date is equal to the index coming from this XTS object and the core data of final XTS, the non-dates. Okay, no row names. Okay, and then convert as a table, which is a special data frame. And then let's check, class, and rows of final table. So we have how many rows? 2213. For this one, uh, n rows na lang. N rows. Okay, 2213, same thing. The only difference is that this is a data frame, a table. This is an XCS object. Okay, so we now have our clean data class. This one, our final XCS. So whether it depends on what we're going to use, it depends on the requirement of the machine learning. Okay, if it's an XCS object, we use this. If it's a table data frame, we're going to use this. Okay, so next meeting class, what we're going to do is now we're going to do the feature engineering. Feature engineering calls for uh, preparing your variables, preparing both the target and the features. So next Tuesday class, that will be. I intend to save on time class. I intend to send you before the class the some of the codes, so that when we go there, I'll just show the codes that you're going. I want you to write. You're going to write it, but the others. Okay, so make sure you download that. Okay, paki-feedback nga class kung mm, hindi pa tayo nakapag-machine learning, ano, we're just on the process of doing feature engineering. But did you learn something, class? I hope you did today.